Hello folks, and welcome to this lesson on fossil fuels. By the end of this lesson, you should be able to evaluate the amount of carbon dioxide added to the atmosphere when different fuels burn, and evaluate the effects of burning different fossil fuels on greenhouse gases. Now, greenhouse gases are gases that will absorb heat energy and release it over time. Now, greenhouse gases, despite what's being spoken of them, is needed for humans to live on the earth and other things for that matter as well. Because if you don't have greenhouse gases, you can get what's happening on places like Mercury and the moon, where you have really, really high temperatures in the day, but you still have very, very, very cold temperatures at night, where all the water that exists is going to freeze overnight because of the fact that there's nothing holding on to the heat during the daytime. So when the planet is turned away from it, there's no way for there to be any heat gain. Greenhouse gases help with that because whatever heat was absorbed by these gases during the day is released overnight. And so that's why the temperature is a lot more moderate than you would see on, again, like places like Mercury. Now, it is necessary for life, but it is a little bit problematic, or things are getting a little bit problematic with these greenhouse gases. And a lot of that has to do with anthropogenic greenhouse gases. So there are processes that create greenhouse gases naturally, that is. You have things like bogs and swamps that create methane. You can have a forest fire happening because lightning struck a forest and it keeps on spreading, and so you get carbon dioxide being produced there. The problem, especially to people, is the ones that people are creating, the greenhouse gases that are of human origin, the anthropogenic ones. So greenhouse gases have always been around, and there always have been fluctuations with greenhouse gases as well, depending on what's going on, what kind of level of life we have, the other situations going on because of various astronomical events. You are going to have fluctuations in carbon dioxide, and the overall temperature of the Earth's atmosphere is also going to change as well because of it. However, we as humans made so many greenhouse gases ever since the Industrial Revolution that by the time we hit 1911, the Earth reached levels of carbon dioxide that have never been measured before up till that point. And those values keep on going up. They have kept on going up. There's no sign of any downturn. And because of the fact that these greenhouse gases are able to absorb heat and then release them later on, we just keep on absorbing more heat, and so everything keeps on getting hotter. The whole global warming thing. Now, there are many types of greenhouse gases. We have things like water, we have methane, and we have carbon dioxide. Those are all made by both humans and nature in general. And then we also have the purely anthropogenic ones like the CFCs. But the one that is causing the most grief in general is that carbon dioxide. Carbon dioxide as a greenhouse gas is pretty effective, but the issue is the quantity that is being made. And a lot of it is because we burn things to make electricity that we can then use, or to make other energy that we can then use to do other things. Now, before we start directly comparing different fuels that we use to burn to create energy, we're going to have to look at this idea called specific energy first. Now, specific energy is a quantity of heat energy released per mass of fuel, and this is going to be a little bit different than some of the values that you might calculate using delta H naught of formation or delta H naught of combustion or anything like that. One of the reasons that it is going to be a little bit different is that specific energy is going to take into consideration some other factors that will affect how well something burns. So, for example, you can have something that could have a lot of potential energy, where theoretically the heat of combustion can be super, super huge, but due to other factors, it's not able to interact with oxygen. It doesn't have enough surface area. It's in solid form, that sort of thing. And so because of that, you get more incomplete combustion, and that means you're going to get less heat released as a result. Having your fuel go under complete combustion is going to give the most amount of energy per mass of that fuel. And if that's not going to happen very effectively, then you'll have to burn more of it to get the energy that you need. Now, one of those factors that will decrease the specific energy is if that fuel is typically at solid or liquid state. The reason for this is because when you have a gas, you mix it in with your oxygen, all the particles are going to easily mix, and so there's more contact with oxygen. It's going to undergo complete combustion very easily. However, if you have a solid or a liquid, only the surface of that solid or liquid is going to be able to have contact with oxygen, and so only that limited space is going to be able to undergo complete combustion. This is why when you take a look at something like a car and you look at how the engine works, part of how that engine works is it takes the gasoline and it sprays it so that you have very, very small droplets of it that are then going to go kaboom, and then that makes your car go forward. And to remind you of how the solid or liquid thing works, if you have strong intermolecular forces that bind that compound together, then you're going to have something that's more likely to be liquid or solid. And if you have some of those bigger chain carbons that are less polar, the bigger chains are going to have more London dispersion forces, and so they are going to have those higher melting and boiling points. So here we go. We have a bunch of different fuels, and you can see that some of them have a bigger specific energy than others. So as you can see, wood and coal, those ones are solid when you start using them, and so these do have those lower specific energies, whereas natural gas is in gaseous form, and so this has a higher specific energy. So if we're thinking about choosing what fuel to use, yes, the state is going to matter a little bit in terms of practicality, because you're going to need to transport this stuff and store this stuff before you use it. But typically, you're probably going to want to go with something that has a higher specific energy, because you can get more energy out of it with the same mass. This being said, at the end of the day, all of these are going to release carbon dioxide when you burn them, so they're not going to be great for greenhouse gases, or rather, our climate in general. That's the end of this lesson. I'll see you next time.